In this video, we're going to go over word problems involving systems of equations. Normally, if we have one unknown, you need one equation to find that unknown. If you have two unknowns, then you need two equations to figure out both of those unknowns. Three unknowns, you need three equations. Four unknowns, you need four equations, so forth and so on. So with the systems that we're going over, we have two unknowns. So we're going to use systems of equations where there is more than one thing that we're trying to find. Here's a simple word problem where you're trying to find two unknowns. You're trying to find two numbers. And those two numbers, when you add them up, equals 12. And then when you subtract them, it equals 4. So what we're going to do is we're going to set up two equations, and then we're going to solve using systems for those two equations. This first equation comes from this right here, the sum of two numbers. The sum means I'm adding them. I'm going to add these two numbers, and they're going to be equal to 12. I don't know what those two numbers are, so I'm going to use two different letters to represent those two unknown numbers. I'm going to go x, and since it says sum, plus y is equal to 12. There's my first equation. This equation goes with this first part right here. The sum of two numbers is 12. Then I'm going to set up a second equation. The second equation is telling me the difference of these two numbers is 4. So difference means subtract, so I'm going to subtract these two numbers, and when I subtract them, I'm supposed to get 4. Right now, it looks like these two equations I've set up are in standard form. Since they're in standard form, it would probably be a good idea for me to use elimination to solve this. So that's what we're going to do. We're going to use elimination to solve this. The first thing I need to do is push these two equations together and see if one of the variables is eliminated and the y's are eliminated. So x and x put together is going to give me 2x is equal to 12 and 4 is 16. Solve this simple equation by dividing both sides by 2. X is equal to 8. So one of my numbers is 8. To get the other number, I simply plug this into that first equation right there. When I do that, it looks like this. I subtract 8 from both sides. Y is equal to 4. So there are my two numbers. My two numbers are 4 and 8. These two numbers right here, when I add them up, give me 12. But when I subtract them, it gives me 4. Another type of problem you'll see that involves systems as equations is one like this. I have two unknowns. That's the reason I need to set up two equations. My first equation is going to be set up from this right here, the perimeter. How do I find the perimeter? The perimeter is the distance all the way around an object. What kind of object do I have? A rectangle. So what I'm going to do is I'm going to draw a simple picture of what's going on here. I've got a rectangle. And for a rectangle, I have length. This is the length, and this is the width. To find the perimeter, I need to add all these together. So if you remember, I can combine like terms. Letters that are the same can be put together. So I could say L plus W, I'm going around in this direction, plus L plus W. When I add all four of those together, it's supposed to be equal to 180 feet. What I'm going to do next is combine like terms. All the L's go together. So I've got two L's. So I'll write 2L. Combine the W's together, that's 2W. This is my first equation. But to find two unknowns, to find L and W, I need a second equation. That's where this part comes in right here. It says if the length of the rectangle is 60 feet more than the width. So what it's saying is the length is means equal to 60 feet more than the width. That means I take the width and I add 60 feet to it, and I'll have the length. The length is longer than the width. So I've got two equations here. Here are my two equations. I've got a choice I need to make. I'm either going to change these into slope-intercept form, or I'm going to change them into standard form. What I'm going to do is I'm going to change this bottom one into standard form. I'm going to subtract w from both sides. These are not like terms. I have minus w plus L is equal to 60. Now I'm going to bring this other equation right here and set it down below it. Look at the way I've got these written. I'm just going to switch this around to where it says 2w plus 2L equals 180. I've taken this equation right here and I've moved it right here. This one is the same as this one. What I did is I switched the positions of these so that all the W's and all the L's were lined up. I'm going to try to eliminate these W's. To eliminate this W, it would be nice if this up here was a negative 2W. It would cancel out a positive 2W. So to change this, what can I multiply to this to change it into negative 2W so it cancels out this 2W? I'm going to multiply everything times 2. And I'm going to rewrite that equation right there when I do that. 2 times negative w, negative 2w. 2 times L, positive 2L, is equal to 2 times 60, 120. Now I combine these together and eliminate one of those variables, the w. 2L and 2L, 4L, is equal to 180 and 120 put together, 300. Divide both sides by 4. Take my calculator out. 300 divided by 4, 75. The length is 75. Now that I've found the length, I need to find the width. I can take this and plug it into this one right here. That would be 75 is equal to W plus 60. Remember, the width is going to be smaller than the length, so I need to subtract 60 from both sides. The width is equal to 75 minus 60, 15. So the width is equal to 15, and since I'm dealing with feet, that would be feet. And the length is equal to 75 feet. These type of problems where it's the perimeter, set up your perimeter equation and then set up the one for the length. Another type of systems of equation problem involves coins, where you've got a total number of coins that equal a certain value. And we're going to use systems of equations to figure out the number of each one of those types of coins. So, like the previous example, you need to use letters that represent each one of these. In the previous example, I needed to find the length, so I used L. I needed to find the width, so I used W. In this one, I need to find how many quarters and how many dimes. So I need a letter to represent quarters. Q is going to represent quarters. D is going to represent dimes. Now, one thing about these coin problems, this right here is how much money. Notice it's represented as a decimal. $3 is 3.00. I need to represent these coins as decimals as well. If Q is my quarters, I need to represent that as a decimal. Now, quarter is worth 25 cents, but how do I write 25 cents as a decimal? 0.25. D represents dimes. How much is a dime worth? It's worth 10 cents. But how do I write 10 cents as a decimal? 0.10. You need to also realize what the other coins are going to be worth, because you're going to have other coins besides quarters and dimes. You're going to have pennies and you're going to have nickels. So P is going to represent pennies for those type of problems. N is going to represent nickels. A penny is only worth 1 cent. How do you write that as a decimal? Look at the difference between dimes and pennies. 0.01. Same thing with a nickel. A nickel is only worth 5 cents. How do I represent that as a decimal? 0.05. I'm going to use these letters and these decimals to help me set up my equation. So I need to find how many dimes and how many quarters. But when I take those dimes and I take those quarters and put them together, I'm going to have a total of how many coins? 15 coins. This represents how many. My next equation is going to represent the amount of money we're talking about. So when I take my dimes, what I do is my dimes are worth how much? 0.10. And I put that in the front of it because to get the value of the dimes, I multiply that times the number of dimes. Plus the value of the quarters, I take 0.25 and multiply it by the number of quarters. And when I do that, I'm going to get the total of everything. That's going to be $3. That's how I set up my two equations. One of the equations is set up by the number, how many there are. The next one represents money, how much a dime is worth, how much a quarter is worth, and how much the entire thing is worth. This system is set up using standard form. Both of these are in standard form, so it would probably be a good idea for me to use elimination. What I'm going to do is I'm going to try to eliminate these dimes right here. So to cancel out 0.10 dimes, it would be nice if this was the opposite of that. This needs to be negative 0.10 D. So what can I multiply to this to get that? I need to multiply everything in this top equation by negative 0.10. And when I do that, I'm going to rewrite it right there. That's going to be negative 0.0 dimes, negative 0.10 times Q, negative 0.10 Q is equal to negative 0.10 times 15. I know what it is, but I'm going to show you what to do in the calculator. 15 times 0.10 equals, and it's a negative times a positive, negative 1.5. So I've changed this one. I multiplied everything in the top by negative 0.10 to change this to negative 0.10 so that these will cancel out. I now combine these two together. This cancels out. I need to figure out what 0.25 minus 0.10 is. 0.25 minus 0.10, 0.15 Q is equal to, now I take $3 minus 1.5, and I get 1.5. To solve this, I need to do the opposite of multiplying by 0.15, which is dividing by 0.15. I need to divide both sides by 0.15. Q is equal to these divided. So if you need help with that, take out your calculator, take 1.5, divide it by 0.15, and you're going to get 10. 10 quarters. Since Q represents quarters, that's 10 quarters. The total is 15. So I take this and I'm going to plug it into this equation right here. Dimes plus quarters is equal to 15 total coins. My quarters are 10. I subtract 10 from both sides. The number of dimes is going to be 5. You set up your two equations. One represents how many coins there are. The next one represents money. These things will be in standard form, so multiply the top one by something that cancels out either the dimes or quarters. And remember, some problems are going to have pennies, So you're going to have to use this decimal. Some equations, some problems are going to have nickels, so you need to use this one.